And you have until 9:50. 9:50. Yes. You can do it.
Okay.
Good luck.
Thank you.
Okay. Oh, she called numbers?
Yeah,
she
called
called
7, 10,
for-
and 13.
Okay.
She called 3.
Yeah, y'all will go later, like right before activity. That sound good? And I'll text her that.
Did you start?
I'm gonna edit.
Sorry, guys.
It's okay.
Okay, you're off. It's her time. Pretend I'm not in here. I am, but okay.
Okay, guys, so my name is Miss Carter. I am going to school at Arkansas Tech. That's a college in Russellville, and that means that I'm going to school to learn how to be a teacher like Miss Walsh. And so in order for me to become a teacher, I have to practice teaching, because you can't become a teacher if you don't know how to teach, right? And what better way to learn how to teach than practice, right? Okay, so today we're gonna work on subtraction algorithms, and yesterday Miss Walsh worked with you on the first one, and today we're gonna work on the second one, okay? Okay, so we're gonna learn another subtraction algorithm. Okay, so I want you to look at this expression and this number, and I want you to think in your head for a little bit on what you notice about these two things, okay? And whenever you thought about it for a little bit, I want you to raise your hand, okay? What do you notice? Isla, what do you notice about this?
I noticed that, they're just the exact same numbers, but they're in one's an exponent and one's the same.
Gotcha, good, good. Need one more person. Matthias?
I noticed that it's counting by, 100, and then it's counting by 1, and then it's counting by 12 on the other side, and 120, and then I noticed it's 2, and then 200.
Gotcha. So what you're saying is here we have 200, but here we have 2, and here we have 120, and here we have 12, right? Do you know what it is? Do you have any guesses? You're right on. Do you have any guesses? What place is this? What place value?
200.
200. And what place value is this?
2.
The hundreds place, right?
Yeah.
So if there's a 2 in the hundreds place, what number is that?
Is 200.
Good job. And so it's the same with this. So we have 120 in the tens place, right?
Yeah.
But we can't have 3 numbers in the tens place, can we?
No.
No. So instead, we turn that into 12, because 12 times 10 is 120, right?
Yeah.
Right? Everybody
Yes.
get that? Okay, good. Good job, Matthias. So I want you to look at these again, and I want you to tell me what you wonder about them. What questions do you have? Grayson?
I want to know why the first one had the plus and after the 20 is gone, and the second one it doesn't have the plus, just has the 5.
Gotcha. Good job. Millie?
I wonder why one has 320 and the other one just has 385.
Gotcha. Okay. So now we are going to write these down that we talked about. Okay, so I want you to turn to page 49 in your workbook.
Page 49.
Okay, so first we're going to write what we shared as a class that we noticed. So both the expression in expanded form and the number show a unit being decomposed.
You may want to scoot it up just a little bit because the stuff. Yeah.
Decomposed into smaller units.
What page is it?
49. Probably doesn't help that I'm left-handed here. So both the expression in expanded form and the numbers show a unit being decomposed into smaller units. And that's exactly what Matthias was talking about whenever he said that the expression on the left had 200, but the number on the right had 2, because they decomposed that 200 into 2 because it's already in the hundreds place.
851.
49. Get your pencil. I'm going to go ahead and start writing what we wondered, okay? So Millie mentioned that she was wondering why the little numbers and the little digits were crossed out in each, the expression and the number. So why are the parts of the expression and number crossed out. I'll give you just a few more minutes to write, okay? And we're going to move on. Annabelle? After number, it's crossed. Alright, if you're not finished writing, we're going to go ahead and put our pencils down and move on to the next part, okay? Okay, so here we have two algorithms. We have Andre's and Claire's. And yesterday, Miss Walsh taught you Andre's algorithm, correct? Yeah? Okay. So now we're going to learn about Claire's algorithm today. So first, I want you to look at these two algorithms and think to yourself, what makes these two algorithms alike? What's the same? Colton?
The numbers are the same.
The numbers are the same? Yeah. McKinley?
That 4 + 112 equals
Good job. Good job. Let's see. Annabelle?
They both get the same amount in the answer.
Yeah. Well, we don't have any answers yet, though.
They will.
Yeah? You think so? Okay. Aurora?
They're alike because they're using the same numbers. They're alike because they're using the same numbers and they're both using the algorithm. But one's expanded form and one's just.
Good job. Okay. So now I want you to look at these two algorithms and think to yourself, what's different? How are the two algorithms different? Isla?
It's different because they have different numbers. They have the same numbers. It's just they're different because they have 2 and then 8. 5. Not 500 plus 20 plus 8.
Good job.
They just have 528 and not 271 and then 271.
I gotcha. Okay. So they're written differently is what you're saying. Gotcha. Okay. Grayson?
They took away the 5 and they took away the 0
Mm-hmm.
and Clem it is 50 because he had 400 and Clem is from 828 and Clem is going to 500 plus 7 plus 8.
I got you. I think I understand what you're saying. One thing that you guys forgot to mention, how are these numbers written?
Those are not
They're both stacked, aren't they?
Yeah.
Huh? And then, except Andre's algorithm is written in what form?
Expanded.
Good job. But Claire's is written just
Stacking.
normally, right?
Stack.
Yep. Okay. Okay. So both Andrea and Claire found the value of 528 minus 271. How they started their work is shown. So what we're going to do is we're going to work the both of these problems on our paper, and then we're going to compare them, okay? So I want you to turn the page to page 50. So first we're going to start with Andre's algorithm, okay? Can someone raise their hand and tell me if I start from the left side of the problem or the right side of the problem? Do I start with the ones or the hundreds? Dixie? The ones. Good job. So we're going to start with 8 minus 1. Can anyone tell me what that is? Matthias? 8 minus 1. Remember, we're subtracting.
7.
7. Good job. So in Andre's algorithm, we've decomposed our 100, the 500 here, sorry, and we've taken it and turned it into 400 because our 20 borrowed that 100 and we have 120 over here. So now we're going to subtract 120 minus 70. Can anyone tell me what that is? 50. Good job. So we have 50. We're going to make sure we write our plus here because we're still writing in expanded form, okay? So now we're going to move over to our hundreds place. So now we're going to subtract 400 minus 200. Aurora? 200. Are we finished with our problem yet? No. What do we have to do? David, do you know what we have to do? What do we have to do to finish up our answer? Because this is not our answer, is it? No. Do you have any clues, David? What does this plus sign tell us to do?
All of
Yeah, so we're gonna add 200 plus 50 plus 7. Okay, can anyone tell me what that makes? Samantha? 257. Good job. So now we're gonna do the same thing, but we're gonna work it with Claire's algorithm, okay? So remember we talked about the differences. So in Claire's, we have 4 in the hundreds place rather than 400, okay? So keep that in mind whenever we're subtracting. So first we're going to start on the right, just like Dixie said, with the ones place. And we're going to subtract 8 minus 1. And we get the same answer, don't we? 7? Good job. Okay, so now we have a 12 in the tens place. So what number does that give me if we have 12 in the tens place? McKinley? 120. And so that makes this 70, right? Because it's in the tens place. So we're going to take 120 minus 70. And that makes 50, right?
Yeah.
50? Okay. But am I going to write 50 underneath?
No.
No. What am I going to write? 5. Why is that?
Because we're not an expanded form.
Good job. And I can only have one digit. Okay. So now I have a 4 in the hundreds place. So what number does that give me, Matthias?
It gives you 2.
If I have a 4 in the hundreds place. You got it. 4 in the 100s place. Ari, can you help him out? If I have a 4 in the hundreds place, what number does that give me? Jeannie? Yep, because I subtracted 400 if I have a 4 in the hundreds place minus 2, which would make a 200 equals 200, right?
I think he's taking the like just the number itself.
Okay, so now we're going to go down to the bottom of the page right here. Andre and Claire started their subtraction in different ways. How did their way of starting affect the steps to find the difference? Does anyone know? Do you want me to rephrase that a little bit? Okay, so Andre's algorithm and Claire's algorithm started different, right? Earlier you told me that Andre's is an expanded form, right? But Claire's is not. So because we did expanded form with Andre's algorithm, we ended our answer with expanded form and then had to add it. With Claire's answer, we didn't have to add, did we? It wasn't in expanded form, was it? No. The answer was already there, huh? Right? Okay. So okay. For Andre's way of getting started, I had to write part of the expanded form for each step.
It got blurry. This is new.
Okay. For Claire's way of getting started, I only recorded one digit for each place value.
Will you move the mouse up to the top? That's not good.
For Andre's way of getting started, I had to write part of the expanded form for each step. For Claire's way of getting started, I only recorded one digit for each place value. All right, I need you to be writing this. I need you to sit up, please. Thank you. Just a few more minutes, I'm writing, okay? When you're finished writing, make sure you put your pencil down so I know you're ready to move on. Alright, if you're not finished, go ahead and put your pencil down. And we're going to try to solve some of these problems on our own, okay? Alright.
You may have to zoom it out. Move, do your, there you go.
Okay. So Claire used an algorithm to find the value of 538 minus 156. And so notice how she stacked these numbers on top, just like we talked about earlier. Okay, so she started by decomposing her 500 into 400. But instead of writing 400 like Andre did, she wrote 4 because it's in the 100s place. and then she took that 100 and moved it over to the tens place to make 130. But instead of writing 130 like Andre did, she just wrote 13 in the tens place. And so then she went through and subtracted her ones place, her tens place, and her hundreds place. And so she subtracted 8 minus 6 and got 2 for her ones. She subtracted 130 minus 50 to get 80 in her tens. She subtracted 400 in her hundreds place minus 100 to get 300, okay? So I want you to use Claire's algorithm to solve these 4 problems, and they should be on page 52, or 51, I'm sorry. So I want you to use this example, use her work, and I want you to show your work whenever you do these problems, okay? And I'm going to give you 5 or 6 minutes to work on these problems, okay? Okay. Make sure that you're using Claire's algorithm and not Andre's, okay? Claire's is this example right here. Troy, I need you to write it, please. Make sure that you're using Claire's algorithm, okay? Double check your numbers as you're subtracting to make sure that you don't make a silly mistake, okay? Annabelle, I need you working, please. When you're finished with your problems, put your pencil down. All right, just a couple more minutes. Finish working on the problem that you're working, okay? Then we're gonna go over them together as a class. Alright, if you're not finished, go ahead and put your pencil down for a second and we're going to go over these together, okay? So I'm going to work through these with you, okay? So first we're going to start.
You'll need to change it.
Alright, so we're going to start with number 1. So what's my first step that I need to do? Isla?
You need to write 691 minus 358, and then you put a line.
I'm going to stack them. Okay, so let's start by stacking our numbers. So I have 691 minus 358. Okay. If I have 1 of something, can I subtract 8 from it? No. So that means that I'm going to have to take a 10 from the 9, right? So we're going to cross that out. So if I take 10 away from 90, what am I left with? 80. But instead of writing 80, I'm using Claire's method. So I'm just going to write 8, okay? Because it's an 8 in the tens place, which makes it 80. So I'm going to take my 1 and cross it out. And what does my 1 become? 11. Good job. So now are we ready to subtract?
Yes.
Okay. So we're going to start with our 1s, and we're going to subtract 8 from 11. So 11 minus 8 is what? Aurora? 3. Colton, what is 8 minus 5?
3.
Oh, but I said that wrong, didn't I? What did I say wrong? Dixie? 8 minus 5, and what's wrong with that?
You can do that.
Because I'm in the tens place, right? So I should have said 80 minus 50, right? 80 minus 50. So what's 80 minus 50, Colton? 30. Good job. But am I going to write 30 below? No. What am I going to write? 3. Good job.
Or you can do your method where 8 minus 5 is 3.
So now let's go to our hundreds place. What is 600 minus 300? 300. Good job. So Ari, what's my answer? Yep, good job. 333. So let's go to number 2. Okay, so I have 926 minus 584. And I'm writing them stacked on one another.
I was missing one. I put 337.
So what is 6 minus 4? McKinley? 2. Can I subtract 8 from 2?
No.
If I have 2 of something, can I give you 8 of something? No. Okay, so we're going to take this 9, and if we have 900 and we take away 100, how much do we have?
800.
800, good job. But I'm just going to write 8. So if I took from this 100 and moved it to our tens place, I'm going to turn this 2 into a 12, which also means 120 because 12 times 10 is 120. So now let's finish subtracting. 12 minus 8 is what, Matthias?
12 minus 8 equals 8 is
Oh, I'm sorry. I meant to say 120 minus 80, didn't I? I keep doing that. 120 minus 80. Or you want to help him out? 100? Yep, 40. Okay, so I'm just going to write my 4 below. Okay, what is 800 minus 500? Aurora? 300. Okay. So Troy, what's my answer? 342. Good job. So let's go on to number 3. I have 317 minus 182. So first we're going to start with our ones. And I have 7 minus 2. Annabelle, what's 7 minus 2? 5. Okay. I have a 1 in the tens place. Can I subtract 8 from 1? No. So I'm going to have to change that, aren't I? So we're going to take this 300 and we're going to turn it into 200. And we're going to take our 10 and turn it into 110. Now can we subtract? Yes. Okay. So we're going to take 110 minus 80. You know? 30. Good job. And can anyone tell me what 200 minus 100 is? Dixie? 100. And Dixie, what's my answer? 135. Good job. So let's finish our last one. Okay. We have 492 minus 325. I have 2 in the ones and 5 in the ones. Can I subtract 5 from 2? No. So we're going to have to change that. So we're going to take this 90 and turn it into what?
80.
80.
Make this 2 a 12.
Yep, and Ryan said that we're going to make this 2 a 12. Does everyone think he's correct? Yes? So now, are we ready to solve? Yeah, are we ready to subtract?
Yes.
Okay. Can someone tell me 12 minus 5? Millie, can you tell me what 12 minus 5 is? Mm-hmm. Jeannie, do you want to help her out? What's 12 minus 5? Eight. Good job. Okay. What is 80 minus 20? 80 minus 20. Grayson?
It is 7.
60.
12 minus 5 is 7.
It is 7.
12, 11, 10, 9, 8, 7.
I'm sorry, guys. Thank you. Thank you, Ryan. I missubtracted, and 12 minus 5 is 7. Okay. 400 minus 300 is what? 100. Good job. Annabelle, can you tell me what my answer is?
167.
167. I'm just going to rewrite that down here since I messed up. Okay. Okay. So how did place value allow us to use fewer digits when recording newly decomposed hundreds or tens? So see, we have 3 digits here in the hundreds place with Andre's method. But with Claire's method, we only have 1 digit in the hundreds place. So it makes it a little bit easier for us to see clearly each place value, so we don't have all of these extra zeros. So that's the big difference between the two, is Andres uses expanded form with the zeros behind each number and Claire's doesn't. Does anyone have any questions? Is there anything that confused you today? Anything that I need to go over? Yes, Millie? We didn't put. Which problem are you looking at? 1, 2, 3, or 4?
Millie, stop mumbling.
Oh, you're confused on why I have 12? Is that what you're confused over? Okay. So Millie is wondering why I have a 12 here in the ones. So before I had a 2 in the ones place. And if I have 2 of something and I want to give you 5 of something, can I do that? No. So in order for it to work, I had to go next door, like Miss Walsh says, and knock on the door and ask for 10, right? And so I took 10 from 90, my neighbor. And so now 90 is 80 because he gave me 10. Does that make sense?
Yes.
And so now me, number 2, I took 90's 10, and so 10 plus 2 is what? 12. So now I have 12 in my ones place. If I have 12 of something and I want to give you 5 of something, can I do that? Yeah. Does that help, Millie? Yeah? Does anyone else have any questions? Okay. So now we... So now we're going to do our cool down. So I'm going to pass this out. Make sure that you put your name at the top of it. And I want you to make sure that you're showing your work for one, but we're only using Claire's method, okay? Claire's algorithm, okay? So make sure that your name is at the top, you're showing your work, and that you're using Claire's algorithm, okay? Whenever you finish, you can go ahead and turn it in.